slit experiment shows that we might be able to be in two places at once. What does this exactly mean? Well, during the World Science Festival, I attended an amazing talk called Quantum Realities, and it was moderated by physicist Brian Greene, and they discussed the different possibilities of quantum mechanics and what it shows us, what modern day, what it means. So I'll start from the beginning. Quantum mechanics is the study of very, 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 very tiny particles. So if you break us down, we live in something known as the macro world, and this just means macro, just like macro carbs and a protein bar or whatever, that it is enlarged, it's big. So you have macro world, and then you have micro, which is very small, as you guys know, the microscope, and then you have something smaller than that, which is quantum. So if you break us down, we're made up of a bunch of atoms, and then if you break down atoms, that's made up of protons and electrons. And so if you look at those really, really tiny electrons, that is something that is a particle. So quantum mechanics likes to study these things because it shows that mathematically, these operate a lot differently than we operate. So for example, right now I am at a time and a place in New York, on this planet, and it is exactly 1:01 p.m. on Sunday. So in quantum mechanics, with certain particles, because there is something known as a probability, when you are observing the particle, before you take its exact measurement, there are two different options. One, the particle will be in either here or it will be in another place. So let's say I'm the particle. I will either be here in New York or I will be in California. But until that measurement is taken, no one will really know where I am. The other option is the particle will either be in one place and the other place at the same time, simultaneously, which just sounds crazy. But based on mathematics and quantum theory, this is actually a possibility. The way that they figured this out was something called the double slit experiment. And the double slit experiment actually happened by accident, which is really, really funny. The way that it works, let's take this handball, for example. So we'll say that this is an electron of a light particle. So what I'm going to do is, from your perspective, I'm going to throw the ball, and there's a probability that it'll either hit this wall or there's a probability it'll hit this wall. As of now, we don't exactly know. Yes, I have the control of it, and so I can probably adjust it based on the exact angle that I'll be throwing it at, and it can hit there. But hypothetically, let's just say that it's going to be shot and it'll hit either one wall or the other. So there's a 50-50 chance that it'll hit one wall or the other. But when it comes to waves, it shows that the waves are evenly distributed. And what starts to happen, if you were to like throw a wave, it will go through both slits, and then the waves are going to interact with one another. And it'll show that the waves, there's a probability that it can be located here and here at the same time, because that's how waves work, just like in an ocean. Where if a particle, which is limited to one object, one particle, it can only be logically in one place or the other. The double slit experiment shows that every single particle has a wave-like quality to it, and because of this, it actually goes through one way and the other. So to us, this shows that there's always going to be this connection, and there's always going to be this this probability that a particle can be in two places at once. So the way that I look at this is the double slit experiment is, yes, very based on mathematics, and it is an experiment that was done. You do look at it from a different perspective of our place in the universe and our world, and are we here and also somewhere else at the same time? And we just haven't seen the broad scale, because to me, if you think about it, if you really want to analyze this, to us, looking at electrons, they're very, very tiny, and we're a lot bigger. But if you look at the Earth compared to our galaxy or a galaxy cluster or our area of the universe, we're very, very tiny. So what if the way that we see how particles work versus how we work in the macro world, we in a form are on a quantum scale or on a micro scale versus the universe, which may be a macro scale. The next thing I found to be really interesting is quantum entanglement. And what this discusses is when you have something like a helium atom has two electrons. those were created together, both electrons. So let's say I don't have another ball, so I'm going to say this lock is the other electron. Oh, okay, better. Shoes. Okay, so these two converses were created together. So in quantum entanglement, if they were created together and they are a helium atom and they are the two electrons in a helium atom, and they were separated and one was put, you know, here, and then the other one was thrown in California. What this shows is that there is always going to be this connection, this sort of not seen connection between the two converses. There's always going to be something there. There's always going to be some type of strange inner connection. What it ties into now is if, say, two converses were created together, but one was one color and one was the other color. This is a better way to sort of explain it. So say these were created together, these two converses. And they both were electrons, part of a helium atom. One is one color, one is the other color. If they were both put in a box, and then one was kept here, and the other one was given away to California, if simultaneously I opened up the box at the same time my friend in California opened up the box, at the exact same time, I open it and I see red, I automatically know that the other one has to be the gray converse. And when that one is open, I automatically know that this one has to be the red converse. And this has to do with this entanglement. It has to do with this knowledge of knowing that one is always going to be one color, one is always going to be the other color. The way this relates to my electrons is one is always rotating one way, one is always rotating the other way. But until you actually open the box to know which way it's rotating, the probability is that it's rotating one way and it's rotating the other way at the same time. But if I open the box for this one and see it rotating to the right, I automatically know this one's rotating to the left. So that sounds really, really crazy and complicated, and it might not make sense. And why does this even matter? Why should we be studying this type of stuff? Well, we should, because we want to know more about ourselves as humans. We want to understand more about the fabric of space and time, how like interstellar travel works, how light travel works. I mean, right now, we know that, you know, we cannot move physically at the speed of light just yet, as I discussed in one of my other videos. And this is because we are actual physical particles. So if we were to move at the speed of light, we would be breaking down into light particles, which means that we would no longer be this physicalness. I wouldn't have bones, skin, hair, nothing. And so we would no longer essentially exist. And this ties into like quantum teleportation, like in Star Trek. So in quantum teleportation, they disassemble all their particles and then reassemble it. But then that can, for me, ties into your consciousness. If we did not have a consciousness, which some people will say also is our soul, is our spirit, then it would be no problem to do quantum teleportation, because we can just break down our particles and reassemble it. Like, there's literally people working on this theory right now, and they're like doing experiments. It's amazing. But because of our consciousness, there is that probability that you may, like, you know, separate. You will die. Like, you actually cannot be reassembled. Brian Greene spoke about this, is that your particles get broken down and they're not necessarily reassembled. There are particles that are almost like a clone to what you are that are assembled somewhere else. So if I want to travel from New York to Paris, oh, you spoke about this actually in his quantum theories like documentary. If I wanted to go to Paris from New York, there would be a system that already has replicated my exact DNA, particles, everything. So this gets bursted to smithereens. This gets completely destroyed. But then my actual particles are reassembled somewhere else. So I guess the main thing is, what about consciousness? What about your everything that kind of fuels your blood to move and your emotions and your feelings? That's something different. That's something, you know, like that's your soul, I guess. And so anyway. So right now, as of that, that's why we cannot do, you know, reassembling, quantum teleportation, and travel. But I found this to be really interesting. It also works the entanglement with black holes. And this is where the theory of wormholes come in. If you have two black holes, let's say this and this, these are two black holes. And if they are within, for some reason, range of one another, they will orbit each other. And if they start orbiting one another, they start to become entangled. And if they become entangled, it is possible that they can connect and form a wormhole. So I think that that's just beautiful, because, you know, it ties into a lot of how people feel connected with each other. Last thing I wanted to speak about, I'm just gonna end this video with a couple clippings I took from the Brooklyn Bridge stargazing. I didn't actually get to look through any of the telescopes. They had, I think, like 10 telescopes out, and the line was insane, so I ended up not even going through the telescopes. But they were doing this really cute experiment with kids and these like colorful LED umbrellas. I think they were trying to show what like a solar eclipse is like, because I think I ever heard them saying that. I didn't stay for the whole thing because it was just too crazy. They were all walking in circles. But eventually I think it was trying to show like what it's like when the shadow and the light from the sun gets crossed in front of each other and how a solar eclipse happens. So that was really cute. So I have some cool pictures. I'm gonna run them now. And yeah, okay, I had a lot of fun talking, guys. I will see you next time, and I'm going to be publishing my paper soon about the details of these talks I went to for the World Science Festival. So I will talk to you guys next time. Bye! So it's the end of the night, and this is a wrap on the World Science Festival and all the activities I've been doing. It's a huge turnout here at Brooklyn Bridge Park. Just behind me, there's a whole bunch of telescopes. The line has been absolutely insane, and it literally is a conclusion. It's the end of the night, and it is absolutely beautiful, and I have a lot of really cool people here. And yeah, so I will catch you guys next time. I'm probably gonna head over to Columbia University and go for their astronomy outreach program and look at some of the other cool stuff. So thank you guys so much for joining me this year at the World Science Festival, and I'll catch you later. Bye! There are so many people here, it's amazing. All these people are star lovers like me! It's so cool! So many people. I love it. It's really dark so you guys can't really see, but it literally starts here and goes all the way back there. All telescopes. So next year, guys, definitely come by. It's really, really exciting. This is what's going on here. Not quite sure.
Okay.